What planet, or planets, do you come from? Are you from one of our closest neighboring systems? How do you tell time if your planet is tidally locked? We'll be asking all those questions and more on this week's episode of the Ask an Alien Project. Join us, won't you? Hello et bonjour, and welcome to this week's episode of the Ask an Alien Project. The goal of our project is to create a comprehensive list of the questions that we as a species would want to ask of an extraterrestrial if we could sit down and have a conversation with them. Now, you may ask, how can we have a discussion with an alien if we don't even know if they exist? Well, you're right, we don't know. But we're getting closer and closer every day to finding that out. So, we had better get ready. This week, we'll be examining a few of the closest known planets which are outside our own solar system, known as exoplanets. The planets of significant interest to us are the ones which have the potential for harboring life as we understand it. Now, it's also fair to ask why all this focus on planets outside our solar system, when we haven't even fully examined all the objects in our own solar system in our search for life. The rationale here is that while there are promising places to look for microbial life in our solar system, we have not as yet detected any evidence of an advanced spacefaring civilization on any of them. Several places in our own solar system are very interesting and worthy of extensive future research, such as in the skies of Venus, where at high altitudes, the atmosphere isn't all that different from ours. There could conceivably be life forms that are born and die in the upper Venusian atmosphere that we simply have not yet detected. We are also spending an enormous amount of time, energy, and money sending spacecraft to Mars in a valiant but as yet unfruitful search for life, even at the microbial level. Perhaps once astronauts finally set foot on Mars and begin planetary exploration in earnest, even building permanent manned bases and cities there, then we might discover some form of life in the frozen ice at the polar regions of Mars, or even more tantalizing, evidence of an ancient alien civilization which has long since died out, but which has left some evidence of its existence. We already know Mars once held liquid water and had flowing rivers, but so far, no Martians. The moons of the largest planets in our solar system are of extremely high interest in the quest for non-Earth-based life forms. Jupiter's moon Europa and Saturn's moon Enceladus, in particular, have attracted much attention because of evidence that oceans of liquid water may lie beneath their icy surfaces. This evidence, plus discoveries of deep-sea hydrothermal vent, tiny life-form communities here on Earth, suggests to some that these frozen moons might just harbor life deep underwater. However, unless we stumble across a vast underwater empire located in those dark, chilly seas, we'll have to settle for the discovery of microbial or perhaps crustacean-style life forms there. Which leads us to depart our solar system and focus on the exoplanets beyond. The first known exoplanet was discovered on October 6, 1995 by French astronomers Michel Mayor and Didier Queloz, and it was named 51 Pegasi b. This discovery sent shockwaves throughout the scientific community and revolutionized the way we search for objects in space. Generally speaking, the planets are named numerically after the telescope or observatory which discovered them, such as TRAPPIST 1. There are several main methods of locating exoplanets, including direct imaging, astrometry, gravitational microlensing, but the two most promising methods are radial velocity, which is watching a star wobble slightly as the gravitational pull of an orbiting planet gently pulls at the star. And the other and most successful is the transit method. This is where astronomers observe a star and watch for a small dip in brightness as the planet transits in front of the star in question, decreasing its light visible ever so slightly. we have been able to conclusively determine the existence of over 4,500 exoplanets as of the time this video was produced, with the hopes of finding even thousands or hundreds of thousands of more, thanks to the recent launch of the James Webb Space Telescope. This groundbreaking new space-based telescope will be able to see far back in time by observing distant infrared spectrum light, as well as giving us a far closer examination of known exoplanets. Astronomers have encountered a theme amongst the exoplanets that have been discovered so far. They tend to fit generally into four categories: Neptune-like, hot Jupiters, supergiants, and Earth analogs. It is the last of those which we will take a closer look at, namely planets which have similar characteristics to our own planet. An Earth analog would be a primarily rocky planet, as opposed to, say, a gas giant. And this analog would have a somewhat similar size and force of gravity as we would find here on Earth, with an atmosphere composed of similar elements as ours, such as oxygen, nitrogen. There would hopefully be evidence of liquid water, and most importantly, exoplanets which reside in the Goldilocks zone. This refers to an exoplanet located within their star's circumstellar habitable zone, meaning it's not too close to its own star, so therefore not too hot, yet it's not too far away from its star and therefore not too cold. They have to be located in the just right range for life. Now, this is admittedly a rather Terran-centric view of what conditions are needed for life to exist on an exoplanet, meaning we are making requirements for what we think is necessary for life. It would be important to point out that we can't be sure if other forms of life could survive on a planet as hot as, say, Venus, which has a surface temperature of 880 degrees Fahrenheit or 471 degrees Celsius, or life forms which comfortably exist at temperatures as cold as Pluto, such as minus 388 degrees Fahrenheit or minus 233 degrees Celsius. Or life forms which have no difficulties living in an atmosphere composed primarily of hydrogen cyanide or sulfuric acid. And so we must be open to those possibilities. However, let's remain focused on exoplanets which we think have the best possibilities for life as we understand life to exist. So here are a few of the more interesting exoplanets and their systems to search for extraterrestrial civilizations. First, we should look at the KEPLER 186 system. Discovered on April 17, 2014, this system contains several planets that appear to have liquid water, although they are located quite far away at over 492 light-years from Earth. There are 3 planets in the system that are most likely tidally locked, meaning one side of the planet always faces its star, much like one side of the moon always faces Earth. This is due to the gravitational force of the star having a much more powerful effect on those planets, usually from them being much closer. Since they are closer to their star than Earth is to the Sun, they will probably rotate much more slowly than Earth. Their day could be weeks or even months long, if they rotate at all. This could make for tidally locked planets which have a hot, dry side forever in sunshine with little to no moisture, and a cold, frozen, dark side with moisture trapped in snow and ice forever. There would likely be a 20 to 100 kilometer wide sliver of permanent twilight encircling the planet in the transition zone from the light side to the dark side, where conditions might be perfect for life to flourish, yet with some significant social challenges on how best to distribute resources and establish communities. But not all planets in that system have these exact same challenges. In June 2018, studies suggested that Kepler 186f may actually have seasons and a climate similar to those on Earth. Next would be the Kepler 62 system. Kepler 62 is a K-type orange dwarf star very far away at over 1,200 light-years from Earth. The dimmer light from this orange dwarf star allows astronomers to observe the planets in that system easier, as they aren't blinded by the brilliant light of a star similar to ours. Kepler 62b was discovered in 2013 and is quite interesting. Likely covered in water, it is a reasonably warm super-Earth exoplanet. Kepler 62b's mass is 9 Earths, yet it only takes 5.7 days to complete a full orbit of its star. With a higher mass, it could likely have higher gravity than on Earth. Vegetation would be pulled towards the surface. Air molecules would be densely packed together, and there would be likely a thicker atmosphere. Strong gravitational forces also attract more asteroids. Hopefully most of them burn up in their atmosphere, but could make for an amazing meteor shower view much of the time. Kepler 62f is likely also covered in water, but a little colder than Kepler 62b. 62f may be an ocean-covered planet possessing rock and water at the surface, but it's the farthest out from its star, so without a supplementary amount of carbon dioxide, it may be a planet covered entirely in ice. Next is the Kepler 452 system, which has a G-type star, quite similar to ours, located 1,800 light-years away in the Cygnus constellation. Its exoplanet Kepler 452b is very Earth-like. It's most likely a super-Earth with many active volcanoes due to its higher mass and density. The clouds on the planet would be thick and misty, covering much of the surface. This planet takes 385 Earth days to orbit its star. Its radius is about 50% bigger than Earth's, and it lies within the circumstellar habitable zone of its parent star. But what makes Kepler 452b so interesting is its age. At 1.5 billion years older than our planet, raising the intriguing possibility of the existence of ancient extraterrestrial civilizations. Then we come to the TRAPPIST system, a red dwarf star only 40 light-years away. On February 22, 2017, NASA announced the discovery of the most Earth-sized planets found in the habitable zone of a single star, known as TRAPPIST-1. This system of 7 rocky worlds, all of them with the potential for water on their surface, is an exciting discovery in the search for life on other worlds. There is the possibility that future study of this unique planetary system could reveal conditions suitable for life. 3 of these planets are in the circumstellar habitable zone, so most likely to be able to hold liquid water. In February 2018, a closer study of the 7 planets suggested that some could harbor far more water than the oceans of Earth, in the form of atmospheric water vapor for the planets closer to their star, liquid water for others, and ice for those planets farther away. This all makes for the study of these planets so much easier because, as mentioned earlier, a dwarf star is nowhere near as bright as ours, making less starlight interference for our telescopes. Some of these TRAPPIST planets have very short orbital periods, such as TRAPPIST-1H, which orbits its star every 19 days. Oddly enough, these TRAPPIST-1 planets are so close together that if you could stand on the surface of one of them, you're highly likely to see some of the neighboring planets hovering above. So to recap, in the TRAPPIST-1 system, at least 3 planets are very Earth-like, all with possible liquid water oceans, all in the Goldilocks or circumstellar habitable zone. They're not that far away from us, and so therefore these are all prime research targets for the James Webb Space Telescope, and we can hardly wait to learn more about these as time goes on. Something to consider. If we can learn all this about these distant exoplanets using only our current 21st century technology, this means that any intelligent alien civilization with at least our current technology or better at these same distances could be observing us right now. So here are some questions that we would like to ask an alien about their homeworlds if we could sit down and have a conversation with them. If your planet is tidally locked, so you have constant daylight on one side and constant night on the other, then how do you measure the passage of time? Do you use the visible movements of other planets in your system to guide the marking of time, as we use our moon's movements to measure months and predict tidal activity? Is there a class system of sorts? For example, do the privileged citizens live on the bright side, and the underprivileged lived on the dark side? Or is there an equitable balance? Do you have communities that spring up near geothermal vents or volcanic regions on the dark side, relying on that natural energy to sustain life? Or do you simply just inhabit the interstitial zone of perpetual twilight? And if your planet is tidally locked, how does commerce work? That is to say, how do you get goods and services from one side of the planet to the other? How do you cope with perpetual darkness on one side and perpetual light on the opposite? Considering the near complete lack of moisture on the hot side of your planet, but its frozen abundance on the cold side, do you have a cross-planetary trade in ice? How about a cross-planetary trade in electricity produced by massive solar energy farms on the sunny side? Or do you fight wars over precious resources, allowing only the victor to have access to life-sustaining water and precious energy? If your planet orbits around your star in just 19 Earth days, do you have any seasons at all? If your gravity is twice as much as ours, how has life evolved to adjust for the increased weight of everything? With gravity on your planet being so much stronger, has your culture evolved to prioritize the research and discovery of anti-gravity technology in the same way as we have prioritized flight? And does that same cultural necessity explain the seemingly gravity-defying flight characteristics of your tic-tac-shaped UAPs, or unidentified aerial phenomena? If your planet can easily observe 3 or 4 other planets in the night sky from your same system, or perhaps even observe them in daylight, how has your culture responded to it? Did your ancients think that that was where their gods lived? Or did they fear the rise of these planets as some sort of an omen of doom? And how does your culture account for the constant stream of meteor showers, or worse, asteroid impacts, on your high-gravity planet? When did you first voyage to your own neighboring planets, as we are in the process of doing now? Does your species reside on more than one planet in your system? Or do you live elsewhere in the galaxy? And when did you first detect us? And using what method did you find us? All of these questions will require much more research to answer, and we plan on discussing more exoplanet findings and how they apply to extraterrestrial life in future episodes. Speaking of research, if you're working in this field, we would like to learn from you and help you amplify your work to a broader audience. Please feel free to contact us directly or in the comments below. Also, in addition to the usual asking for people to like and to subscribe to our channel, which is a really good idea as we're just getting started, please let us know what questions you would want to ask an alien if you could sit down and have an interview with them. So thank you et merci, and we will see you next time on the Ask an Alien Project.